Hello everyone, it is the quadratic inequality. So today in our lesson we are going to solve together several quadratic inequalities. And as we know previously, we have studied different types of inequalities, and we know now what is inequality. And the quadratic inequality is just an equality with the variable to the second degree or to the power 2. It's the exact same as a quadratic equation, just it holds the unequal sign instead of equal sign. So it has the same standard form as the quadratic equation. Let's see here the general form. As we know, it's ax squared plus bx plus c is greater than or equal to 0, or less than to 0. For example, for quadratic inequalities, x squared minus 6x minus 16 is less than 0, 2x squared minus 11x plus 12 is greater than 0, or x squared plus 4 greater than 0. This is a full square where b is 0, and x squared minus 3x plus 2 less than or equals to 0. As we can see here, all the quadratic inequalities are at the standard form of the quadratic inequality. So it's not always the problem can be like here, like this one in standard form. So if it's not given like this, we have to first make the inequality as the standard form of quadratic equation or quadratic inequality in order to decide what is the method to solve it. Previously in quadratic equations, we have learned how to solve quadratic equation by factorization method and by the use of quadratic formula, by completing the square, and simply if b is 0 by taking the square root. So we have learned different methods to solve such inequalities, and there is no difference in methods between the inequality and the equation. And we always say that a quadratic equation or quadratic inequality has two roots, as we have the variable raised to the power 2. So it always gives two roots. Now let's take an example. See how does this work. We have this example here. Solve the inequality, which is x squared minus 4x greater than 2 minus 3. As we can see, it's not arranged as the standard form of quadratic inequality, so we need first to arrange it in order to decide which method we use. So we have to add 3 for both sides of the inequality. Gives us here plus 3 greater than 0. Now we have this quadratic expression. We can factorize it by product two expressions where both of these factors have x and both of them have a constant. The multiplication of these constants has to be equal to plus 3, and the addition has to equal to minus 4. We have minus 3 and minus 1. So that x is multiplied with x, it gives us x squared, and minus 3 multiplied with minus 1 gives us plus 3 here, and minus 3x gives us the middle term here, which is minus 4x, just to check for the factors. So x minus 1 and x minus 3 greater than 0. So I want both of these terms negative or both of these terms positive in order to solve such an equality. Let's check the signs. We have points of interest here 1 and 3. And if you take any number greater than 3, which is 4, 4 minus 1 is positive. And 4 minus 3 is positive, it's positive. Between 1 and 3, let's take 2. 2 minus 1 is positive, 2 minus 3 is negative. Positive multiplied with negative gives us negative. And if we take from 0, less than 1, for example, minus 1. Minus 1 minus 1 equals the negative, and minus 1 minus 3 is a negative. Negative multiplied with negative gives us a positive. So the solution will be, we need all the x's, which gives us a positive value of this inequality greater than 0. The positive value, it is from negative infinity to 1, where 1 is not included, and from 3 to positive infinity. These are the solution of x. Let's take another example here. Two x squared less than 9x plus 5x, and we need to rearrange it in the standard form. 2x squared minus 9x plus 5 less than, we keep the symbol as it is, less than 0. So we factorize this into 2 factors less than 0. So we have 2x here and x here. 2x multiplied with x gives us the 2x squared. And I need two terms that when multiplied together gives us plus 5 and minus 9 when adding them to each other. So in this equation we have minus 5 plus 1 . Okay, this term here has to be negative. This term here has to be negative, not positive. So 2x plus 1 less than 0 multiplied with x minus 5 multiplied with 0. So 2x plus 1 is less than 0. Then 2x less than minus 1 over 2. So x is less than minus 1. Or x minus 5 less than 0, then x has to be less than minus 5. So the solution are when x is less than minus 1 or x is less than plus 5. On the numbers line we have here 0, this is 5, and this is minus half. So less than, x less than minus half, it means this one minus half is not included, and this time interval and when x is less than plus 5, gives us this one, where x where 5 as well is not included. So let's check the signs. We will take a number over 5, which is 6, for example, and check with 6 multiplied with 2 is 12 plus 1 is positive, and 6 minus 5 is positive. Is positive less than 0? No, it's negative. It's positive, then it's not a solution. Between 0 and 5, let's take 1, for example. 2 plus 1 is positive. 1 minus 5 is negative. It's negative here. And between minus 1 and 0, minus 4, for example. 2 multiplied with minus 1 over 4 gives us minus half, plus 1 it's positive. Multiplied negative, it's negative, sorry. Less than minus half, let's take minus 1. Minus 2 plus 1 is minus, and minus 1 minus 5 is minus. Negative, negative is gives us positive. So the solution of this inequality that gives us less than 0 is between minus half and 5. This interval. Where both of them are not included. Okay, that's it for today's lesson, and I hope you find it helpful. Thank you. See you next time.